Okay, so there's 12 basic functions, and then they're in the textbook. But real quickly, you have the identity function. You can pause the video if you need. Looks like this algebraically, and it looks like this graphically. You've already done it before in algebra. It's y equals mx plus b, but the m is just 1, and the y-intercept is 0. It's supposed to cross at the origin. Okay, that's the identity function. And they call it the identity function because whatever you plug into it, you get the same thing to come out of the function. And I forget what they call this one. The squaring function, a basic quadratic function. Um, whatever number you plug in, it gets squared, and that's the output. That's the y value. So this makes a parabola, crosses at the origin, looks like this. Okay? So I think they call that one the squaring function in our textbook, but the basic quadratic function is fine. Okay, a cubing function, basic graph looks like this. Okay, so that's the third function our textbook lists. They just want you to have a rough idea of what these are, and I know that's pretty quick. You'll probably have to flip back and forth, or pause the video and draw these as I draw them. The reciprocal function looks like this. It has a vertical asymptote at x equals 0. You get infinitely close, but never touch at x equals 0. So this is what the reciprocal function looks like. Whoop. Something like this. Okay, because as you get closer to 0, look, if you plug in negative 0.1, then 1 divided by negative 0.1 is 10, negative 10, right? And if you plug in something really close, like 0.001, 1 divided by 0.001 is 100, so it's a huge y value. The closer you get to 0, the bigger the numbers get. So that's the reciprocal function. The textbook gives us the squaring function, which looks like this. And then if you graph it, squaring function looks like this. Looks like it's going to level off, and it never actually does. Okay, because if you plug in 1, you get out 1. If you plug in 2, you get out 4. If you plug in 3, no, wait, sorry. I said that wrong. If you plug in 1, you do get out 1. If you plug in 4, you get out 2. If you plug in 9, then you get out 3. But that's the square root function. We have a basic exponential function. So this is exponential function base e. And the sketch of the graph looks like this, and we'll study why it looks like that several times throughout this course. Okay, that's an exponential function. Logarithmic functions, we haven't talked about a logarithm yet. You've probably talked about it a little bit in algebra, but if not, that's okay. We'll talk about it in this class. The basic graph looks like this. Vertical asymptote at x equals 0. In other words, we never touch this line right here. Get infinitely close. But that's the curve. The arrow's right here. Okay. So the natural log function, or a logarithm function in general, looks something like this. We have the sinusoidal function. I don't know why they differentiate between sine and cosine. But sine looks like this. It starts at the origin and starts waving, it comes back. Then it repeats the wave going both ways. Okay, so sine starts at the origin. But a cosine function, it does the same thing. It makes the same wave, but look at the difference. Cosine of x, it starts at the peak of that wave at the origin, at x equals 0, I should say. And x equals 0, and it does the same exact thing. It just shifted pi over 2 units from the sine function. So cosine and sine are the same thing. Sine starts right in the center of the wave at x equals 0. Cosine starts at the top of the wave at x equals 0. Then we have the absolute value function. The graph looks like this. Okay? So we just want to get a basic idea of what these graphs look like. We have the step function, the integer function. And all this notation is saying is whatever you plug in, you round down. So that's why if you look in the book, from 0 to 1, it has a line right here. And then I think it has an open circle and a closed dot from x equals 1 to almost x equals 2, open dot. And then it steps up from 2 to 3. Okay, and it keeps going like that. Because any number you plug in on the x-axis, you round down. So 2.9 rounds down to y equals 2. 2.1 rounds down to y equals 2. 2.999, that rounds down to 2. So the integer function gives you integers, but rounding down. And then the last one, this is the logistic function. This looks weird, and you might be thinking, why the heck do we even study something like this? But this does a great job of modeling a lot of phenomena. Okay, like life in general. Let me just think about this for a second. That's one. Ba, 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 ba. Oh, I forgot for a second. I know it looks something like this, but if you plug in negative infinity, you get infinity. That's 0. Okay, so it should look like this. Okay, and it does level off. It has a peak. So when you don't mess with it, it goes between 0 and 1, but it can't go above 1. Okay, so this is like animals in the wild. You eventually they level off because there's too many animals for one location. The predators keep them down. There's not enough food for all of them, so they reach a carrying capacity. They do this with bacteria. Okay, they put bacteria on a slide, give it a little bit of sugar. The bacteria expands until they've consumed all the sugar that's available. It's reached a peak, and it never goes beyond that. So this is good for graphing life. Okay, that's the last one, the logistic function. Okay, so now we have all those. Now we're finally ready to answer the questions here. They want you to match the graphs with their functions. So like we just looked at this, y equals sine of x plus 1. That should be one of these two wavy ones, right? The plus 1, we call that a vertical shift. What it's done is it said, hey, every y value that's possible, bump them up 1. And on the graph of y equals sine of x, if you graph it, and by the way, hey, use desmos.com/calculator for these, okay? Because we want you to get used to these functions. If you graph a regular sine of x, not sine of x plus 1, if you graph that in Desmos, it looks something like this. It goes between -1 and +1. Okay? But if you add a 1 to every possible y value, then you're going to between 0 and 2, right? Because you took the minimum and added it by 1. You took the maximum and added it by 1. So now it should be this graph between 0 and 2. So that's A. And then the only one other trig function that could make a wave is cosine. Look, the negative, multiplying by a negative, instead of starting at the peak of the amplitude, the peak of the wave, then you just start at the bottom because you've changed every y value from negative to positive and vice versa. So this has to be B. Okay, C, it's e to the x plus 1. So this is that exponential graph. I don't even remember doing the exponential graph. It should look something like this, okay? If you do plus 1, then you've just shifted it up 1. You might not know that right off the bat, but you will know that after taking this course, okay? So go ahead and graph these in Desmos. But e to the x plus 1, that should be this graph right here. That's the structure we just looked at. D, y equals x squared plus 1. So this is a parabola, just bumped up 1 unit. So that's this one over here. E, y equals negative x to the third. So this is the correct graph for E. You could graph that in Desmos, but that makes that curve that we talked about for x to the third. It's just going in the opposite direction because you multiplied by a negative. F, x minus 1. We'll talk about what this minus 1 does. It's a horizontal shift to the right 1 unit. So that is going to be the other one that makes the x to the third graph just looks like this. G, absolute value graph. Do we have any other V's? This is the only V, so this has to be G, right? That's what matches our 12 basic functions. H, 1 over x, the reciprocal. If you look in your notes, look in the textbook, or you go back in the video, when we graph the reciprocal, that was this one here. I is y equals x plus 1. So that's shifted up 1 unit, so that's this one. J, the square root of x plus 1. This is the graph that matches a square root graph. K, the integer function, that step function that we talked about. I didn't draw that one. Then L, the logistic graph. It's just multiplied by a negative again, so that made it do a wonky shape. So they really just want you getting comfortable with the graphing calculator matching these graphs.